People are often unnecessarily flexing when it comes down to hardware hacking, so therefore let me show you some easy options when it gets to firmware extraction. We start the series with some options if you have an UART shell. We could use a cheap UART adapter from Adafruit, but for the flex, let's take the bus pirate to extract the firmware from this device here. Back to series. If you have a UART root shell and network capabilities, we can use a lot of binaries to extract the firmware from this device. They are fast and they are reliable, and here we've got a few examples. We could use netcat, wget, SSH, telnet, FTP and even more. In this video we are going to use netcat. We establish the connection to our bus pirate with the GTK term and select the UART mode. We prepare our connection parameters, basic UART settings, and now we enable the bridge mode. This will proxy the UART bytes from the device to our laptop and vice versa. We power on the device and fast forward the output until we hit our root shell, and then we have to select the green terminal color because otherwise no one will watch this video on YouTube, right? Absolutely. The firmware itself can be extracted via MTD block devices. We can simply cut them out and pipe them through netcat. We also need to start our listening service on our laptop, and now we can extract the whole firmware over the network. After a few seconds we are done. We are creating an MD5 sum for later reference and taking a quick look into it with binwalk. Looks good, perfect. Okay, cool story bro, but not all devices have network connection. Yes, if you are not having access to these binaries, we could use local tools like XXD, hexdump or base64, which is often included in tools like OpenSSL. So now we are locally on the device and therefore we need to print out the block device, but this time we store the output of the terminal in a local file. We create our log file in GTK term and check if base64 is available. Okay, not directly, but maybe in OpenSSL. Yep, this seems to work out. Now we can print out the block device and pipe the output through base64. Before we move on, we should clear the log file first. And now we can start. This process takes significantly longer. I mean, not just a little bit, it's quite huge. After getting the output, we now need to get rid of the characters at the beginning of our file and later also the new line characters in our file. We also need to clean off the end of the file because there we still got some terminal output printed in there. Now we have to get rid of carriage return and new lines, and now we can cat it out and base64 decode all of it. This process is a little bit more complex, but it works out at the end. We can see the MD5 sum is the same. Yes, they are the same. Okay, not sure if you do a lot of hardware hacking, but hexdump, base64, these are not really available on many devices. Yes, if none of these are available, we have to get into our final form. And to reach our final form, we have to go even further beyond. Yes, our final form is cat, and we have seen this approach before. So this method should work if all the other options fail. Once again, we need to print out our MTD block devices and log them into a file. But this time we have to switch to the hex view, because otherwise we wouldn't be able to distinguish between the single bytes. Once again, this process takes quite a while, but nevertheless it looks absolutely awesome, right? Absolutely. Now we need to stop our log file and we perform a little bit of a cleanup. We open it up with imhex and we delete the first few bytes, representing our enter key we have pressed before. Afterwards we go to the end of the file and delete the terminal output which was printed after our firmware extraction was completed. Okay, now we have to do something different. We need to replace now the 0D 0A characters with 0A. I have diffed a lot of binaries to figure this out, and this works reliable with the GTK term. No worries, we are not stripping away other important new line characters from the firmware itself. Trust my process here. We make this modification and now we've got a clean hex dump. We can now use the XXD tool to get back a binary format out of an hex dump with the option -P-R. XXD is now available because we are on our laptop right now, not on the device anymore. This time we're extracting it. We could use binwalk, but I will show you another video that shows you why you shouldn't use binwalk to extract this file. So therefore we are choosing a manual approach with DD. As an input file we take our firmware bin, as an output file we name it squashfs. Block size is 1 and we count these many bytes because this is the size of our squashfs file system. We run this command, which will now extract this squashfs out of this firmware blob here. We can use unsquashfs afterwards to get back the original firmware, and here we've got it right now. Awesome, right? We can now start our vulnerability analysis or simply take a look into the etc shadow to figure out that there is no root password. In the next episode, we take a look into the firmware extraction if we are not having a root shell, and there we will play along with the bootloader. And this is something you definitely don't wanna miss. Believe me, it's awesome. So I hope to see you there.